My name is Manju Singh. I am an assistant professor at HR Group of Institutions, Ghaziabad. Today I am going to teach Research and Methodology, Semester 8. Today's topic is Unit 3rd, Blocking and Confounding System. So, here we start. First of all, I want to explain what is biostatics. Biostatics is in which we summarize large data in a uni, in a unit digit. For example, in a chemist shop, when you go in a chemist shop and give your prescription to pharmacist, the pharmacist then they take out the medicines according to the prescription so fast, but how do they do it? uh, without arrangement of medicines in a systematic way, they cannot find the medicines. So to summarize or to arrange all the medicines according to alphabet or any other system, so they can take out the medicines very easily and in a very less time. This is also called as blocking system. Like, they make different blocks for different medicines. If you ever went in any pharmacy of in any hospital, you can see that there are different blocks or different departments for different medicines. Like there is a diabetes section, there is a hypertension section, different sections for different medicines. So can the pharmacist can easily take out the medicines for the individuals or for the refer patients. And also there is a different system, like they arrange medicines in a small pharmacy. Like you see in your neighborhood the pharmacies, they arrange medicines according to alphabets, like alphabetic order A to Z. They make blocks, or they make different boxes according to alphabets A to Z, and the different medicines are named with A. The medicine name with A are they put them in box with name A, and so on, B, C, D and Z, so they can easily take out medicine, they can easily take the medicine out. There are also many softwares which help them, so they can click on the software, and the software tells them in which box the medicine is you have put the medicines. But in software you have to put the details manually. So my concern is that all this arrangement is known as the blocking system or confounding system. For a very simple example, in your kitchen you put so many utensils. Like you put plates in one section, spoons in one section, so you can easily find them. If you put everything on the table, so it is very hard for you to find the uh, utensil you required at that time. Like in big hotels, there are orders came randomly, and for them it's very hard to take out the utensils for the uh, required menu. So they put everything according to order and summarize them. This is known as blocking system. So also uh, in this chapter, statics means you put some formula or any other thing and to summarize large data into a unit digit. So here is the introduction. Here there are many situations which is to all of the runs in a 2k factorial experiment under homogeneous conditions. 2k factorial you have already read in your previous units in unit second or third. What is 2k factorial? You have already read in that units. So a single batch maybe not be large enough to make all of the required runs. It means a single batch of raw materials is not perfect to make all the requirements. Here is the second example. For example, a chemical engineer may run a pilot plant experiment. First of all, you should know what is pilot plant. You have already read the pilot plant in your first unit of industrial pharmacy. Second, in 7th SAM, pilot plant is like a copy when you do an experiment or research on a small level and then scale up it on a large scale, that is called pilot plant. So pilot plant is like a small study on a small level. For example, like you want to make a software or you want to make a medicine for coronavirus, then but before launching it on a very large scale, you do experiments in your lab or you do any experiment in your class laboratory, you do practicals. So the practicals in your class you done on a very small scale. So that is called pilot plant, the study of or doing experiments on a small scale before applying it on a very large scale. That is called pilot plant. So the chemical engineer may run a pilot plant experiment with several batches of raw material because he knows that different raw material batches of different quality grades are likely to be used in the actual full scale process. It means when we do any experiment in our lab, we take only one batch because we are only doing experiment, but when you apply it in any company or on a very big scale, you need several batches. Because why do we need several batches? Because different raw material batches have different quality grades and that are likely to be used in the actual full scale process. It means when you do something on a very large scale, you can't rely on a single batch. You need to check various batches of various raw materials. So which raw material can give the best result or which raw material has the best quality. So next is blocking system. What is blocking system? I have already gave you example what is blocking, arranging things in a block. So blocking is a technique for dealing with controllable nuisance variables. There are variables and you have to deal with the variables, how to arrange them. So the technique by which you deal with the variables is known as the blocking. Blocking is simply means like you make blocks, different blocks. For example, I have told you putting different medicines like A name, A name medicines. The medicine start with the name A. You put them a block A, and medicine with the name B, you put them in block B. So you can easily take out them. When a prescription came to you and you read the name with A, B, you directly go to A. It is not like all medicines are not put it here. A, B, C, D, all are not mixed. You simply arrange them in different blocks, so you can easily take out them. So blocking is in simple means this is the way of blocking, and it is a technique for dealing with controllable nuisance variables which different variables. Suppose that the 2k factorial design has been replicated n times. 2k factorial you have already ready in your previous units, 2k factorial designs. Then each set of non-homogeneous conditions divides in blocks and each replicate is run in one of the blocks. It means there are different blocks and each set of non-homogeneous conditions. Non-homogeneous means they are different. Some is A, some is B, some is C and D. Different variables are put in different blocks. Each replicate is run in one of the blocks, means A, B, different blocks C. Runs within the block are randomized, and within the block they are randomized. Next, for example, consider the chemical process experiment. Like the chemical engineer wants to do an experiment with several batches of raw materials. So the same example, the chemical process experiment, this investigation is into the effect of the concentration of the reactant and the amount of the catalyst on the conversion in a chemical process. It means the chemical engineer who was conducting the experiment in this investigation, here is the he wants to check the effect of the concentration. It means this is one variable, effect of concentration of the reactant is one variable and the amount of catalyst is another variable on the conversion in a chemical process. When there is a chemical process, so he wants to check the concentration of the reactant and the amount of the catalyst. Next, the reactant concentration was factor A. Here the one variable is factor A with two levels of interest, 15% and 25%. It means the reactant concentration, the variable name reactant concentration has also two different variables, like one is 15% and second is 25%. The first the factor A has two units, like first is 15% and in second its concentration is 25%, and on this the amount of catalyst, the catalyst was factor B, another variable with the high level denoting the use of 2 pounds of the catalyst and the low level denoting the use of only 1 pound. The experiment is replicated 3 times. It means we have two variables. One is factor A, which is reactant concentration, in which there are two concentrations. 2k factorial means we take two values. 2k factorial means two values. We run only two values, like here 15% and 20%. Factor A 15% and 20%, and the second factor is factor B is catalyst concentration, catalyst amount. So the first amount is 2 pound and the second amount is 1 pound. So there are 4 runs, like for example here 15%, 25%, 1 pound, 1 pound, 2 pound, 2 pound, 4. And this experiment is replicated 3 times. Next, suppose that only 4 experimental trials can be made from a single batch of raw material. It means with A 20%, 15%, catalyst 1 pound, 2 pound, we can conduct only 4 experimental trials in a single batch of raw material, but we have to replicate it 3 times. Therefore, 3 batches of raw material will be required to run the 3 replications of the design. It means what I said, factor A has two concentrations, 20%, 15%. Catalyst has two amounts, 1 pound, 2 pound, and we can make only 4 experimental trials in a single batch. In a single batch, 4 experimental trials, and we have to run 3 replications of this. So we need 3 batches. So how do we do it in next? So here we can see chemical process experiment in 3 blocks. How do we conduct chemical process in 3 blocks? So this is block A, block B, block 2 and block 3. Here A value is 36, B equals to 18 and AB equals to 31. In second block, 1 equals to 25, A equals to 32, B equals to 19, AB equals to 30. In block 3, 1 equals to 27, A equals to 32, B equals to 23 and AB equals to 29. Here B1 equals to 113, B2 106 and B3 is 111. We can see here in simple arranging anything, we just put things from one place to another, arrange them in blocks, but in blocking system this is related to statics, so we put some formulas and then make blocks. Here you can see the values, you can create them after making after putting statics into this. Next is confounding the 2k factorial design. What is confounding? Actually, blocking and confounding are same, but what is the difference? Why do we use confounding? So difference is there are many problems for which it is impossible to perform a complete replicate of a factorial design in one block. In previous blocking system, we can see clearly we were using only simple blocks like A, B, C, block 1, block 2, block 3. So if there are so many problems in which it is very difficult to replicate the factorial design. Actually in previous blocking system we just made a one block and then we replicate it 2 times. We replicate the trial batch 3 times, but here it is very complicated to replicate of a factorial design of one block. So in that case we need confounding the 2k factorial design. So what is confounding actually means? Confounding is the design technique for arranging a complete factorial experiment in blocks, where block size is smaller than the number of treatment combinations in one replicate. It means confounding, it's a type of design in which we arrange a complete factorial experiment in blocks, where block size is small than the number of treatment combinations in one replicate. The technique causes information about certain treatment effects to be distinguishable from or confounding with blocks. In this chapter, we focuses on confounding systems for the k factorial design. Here k factorial related to 2k factorial. We consider the construction and analysis of the 2k factorial design in 2p incomplete blocks where p less than k. In this chapter, we will consider the 2p incomplete blocks where p is less than k. K means 2k factorial. Therefore, these designs can be run in 2 blocks, 4 blocks, 8 blocks and so on. Why? We consider the construction and analysis of the 2k factorial design in 2p incomplete box, where p is less than k. Confounding the 2k factorial design in 2 blocks. Suppose we wish to run a single replicate of the 2k design for treatment. I have already told you, when you take a single batch, you have 4 treatment, like 4 trials, like A has 2 reactions 15, 20 and catalyst has 2 values 1 pound and 2 pounds. So, 4 treatments in single replicate, 4 treatment. Each of the 4 treatment requires quantity of raw material. For example, each batch of raw material is large enough for 2 treatment combinations to be tested. 2 batches of raw material are considered as blocks, then we must assign 2 of the 4 treatment combinations to each block. The order in which the treatment combinations are running within a block is randomly determined. Also, which block to run first is randomly determined. Here we can see there is a block B. Here is the value like this. Sorry, this is here and this is here. Okay, so the dot run in block 1 and here this sign is run in block 2. This is block 1, this is block 2. So, block 1 AB and block 2 AB. Here we want to estimate the main effects of A and B just as if no blocking had occurred. Because suppose there is no blocking, then A equals to half AB plus A minus B minus 1 and B equals to half AB plus B minus A minus 1. Here we can see A and B are unaffected by blocking because in each estimate there is only 1 plus and 1 minus treatment combinations from each block. Any difference between block 1 and block 2 will cancel out. A minus B here. Now, the interaction AB here is because the 2 treatment combinations with plus sign AB and 1 are in block 1 and the 2 with the minus sign A and B in block 2, the block effect and the AB is confounded with blocks. All the treatment combinations that have a plus sign on AB are assigned to block 1. It means plus sign assigned to block 1 and minus sign to block 2. This approach can be used to confound any effect AB with blocks. Next example, B had been assigned to block A and B to block 2. The main effect of A would have been confounded with blocks. The usual practice is to confound the highest order interaction with blocks. Next is table of plus minus signs. Here we can see if there are 2 blocks A, B, A, B, then plus minus always minus, plus plus, sorry, here you can see I plus A plus minus plus minus plus B minus minus plus minus. You can see minus minus plus, plus minus minus, plus minus plus minus and plus plus plus. This is a scheme used to confound any 2k factorial design. From the table of plus and minus signs in table, we assign the treatment combinations a minus on the ABC to block 1 and those that are plus on ABC to block 2. Again there is a table A B C A C A, plus minus minus plus minus plus plus minus, plus plus minus minus, and here minus minus plus is plus, 2 minus plus 2 minus plus, plus minus plus minus minus, plus minus plus minus plus, you can calculate easily. Here again you can see plus 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 1 2 3 4 and 3 minus, so result is minus, plus minus 2 minus plus 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 2 minus plus plus 2 plus 2 minus plus plus 1 minus, तो minus, plus minus plus minus plus minus plus minus, plus 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 plus. So this is a table of plus and minus signs for the 2 raised to power 3 design. Earlier we have seen, here we can see this is a 2k factorial design, 2 raised to power 2, AB and AB. Here, and the next table is 2 raised to power 3 design, in which we take values AB, AB, C, AC, BC and ABC. Final result is ABC. Okay, next is thank you.